Hello guys, today we are studying resolution of forces. Resolution is nothing but resolving any force. Resolving means what? Resolving into what? Horizontal and vertical components. Why are we doing so? Because our system is two-dimensional system. One, we can consider horizontal axis and another we can consider vertical axis. This is our system where we are considering two planes at a time. Either we can consider x or y or x and y together. But it is difficult for us to consider the Cartesian plane or inclined force or anything along the inclined axis or z axis. So what we have to do is whenever we get a force in the Cartesian plane, or we can say whenever we are getting a force in the z axis, we have to resolve it first. We have to resolve it means we have to convert it into horizontal axis and vertical axis. That conversion will call it as resolution of the forces. So let us say we have a force F like this and we need to resolve it. We need to convert this force into horizontal and vertical component. So very first thing what we have to see is whether the angle of inclination, this force is angle of inclination is whether with x-axis or whether with y-axis. For that, what you have to do, very first thing, whenever you get of inclined force, just draw a quadrant system. As we know there are four quadrants, you have to just a quadrant system with x and y axis and check whether the angle is with x axis or with y axis. What does it mean with x and y axis? Means whenever we have the angle in between the force and the x axis, we'll call it as angle is with respect to x axis. And similarly, when we have the angle between the force and the y axis, we'll call it as angle with respect to y axis. So in general what we can say is we can get two cases. Case 1 is what? The angle of inclination of the force F is with respect to x axis, and case 2 is angle of inclination of the force F is with respect to y axis. Now how to resolve this? Let us see in detail. Well, first thing, whenever you get a force, just draw here one perpendicular. As we draw one perpendicular head, what does it turn? This turn into right angle triangle. As we know, the horizontal component of this resolved force F will be f of x and the vertical component of the resolved force will be y of x. This y of x is correspondingly equal to here y of x. Now just consider this right angle triangle. We have theta here, f of x and f of y. This is our force F. We have to find out what are the values of f of x and f of y. What we can do here is we can just apply trigonometric functions. Trigonometric functions, that is cos theta and sin theta. As we know, cos theta is what? Adjacent by hypotenuse. Now let us check which is adjacent and which is hypotenuse. Adjacent means adjacent side of the triangle. Adjacent side of the angle in the right angle triangle. This is a right angle triangle. As we know, this is 90 degree. We are not concerned of this angle right now. We have to concern this angle. We have to take in concern this angle theta and check the adjacent side of the theta is this side, f of x. So adjacent, what we have written here is, we can say f of x and the hypotenuse is f. So cos theta is equals to f of x by f. What we need? Horizontal component f of x. So f of x is equals to cross multiplying this f cos theta. So when we have angle with respect to x axis, the horizontal component of the force f of x is equals to f cos theta. And then now let us see how to calculate or what the value we'll get for f of y. So we have here sine theta. Sine theta is what? Opposite side divided by hypotenuse. Opposite side of what? Opposite side of the angle theta. Opposite side of the angle theta is this side, f of y. We'll write here f of y. Hypotenuse is again the force f. So sine theta is equals to f of y by f. And what we want right now is f of y, vertical component. Vertical component cross multiplying here f sine theta. So whenever we get an angle with respect to x-axis, what is the resolution of f of x is? F of x is what? F cos theta. And resolution of f of y, it is f sine theta. We got with respect to x-axis. When angle is with respect to x-axis, that is in between the x-axis and the force. Horizontal component f of x is f cos theta, vertical component f of y is f sine theta. Now let us check for the second case. Second case is what? When the force is inclined and the angle is in between the force and the y-axis, that is the vertical component. Angle is with respect to what? Vertical axis, with respect to y we can say. We have to calculate f of x and f of y. So similarly, just draw a perpendicular from y-axis. You have angle with respect to what? With respect to y-axis. So you have to draw perpendicular with respect to y-axis. As we have drawn this perpendicular, this vertical will be equal to f of y, horizontal will be equal to f of x. Now just consider this right angle triangle. It is something like this. This is our force f. We have theta here. This is f of x and this side is f of y. Now again using trigonometric function, we can see cos theta is equals to adjacent by hypotenuse. Adjacent side of this is the angle is in between the force and the vertical line. So adjacent side is definitely the vertical line. It can't be a force f, inclined force. It cannot be inclined force. It has to be the vertical or it has to be a horizontal. But here in case of this vertical with respect to vertical axis, vertical side we have got it as what? Vertical side we have got it as adjacent side. So we have to write it here. Adjacent side is f of y. Hypotenuse is f. And therefore cos theta is equals to f of y by f. And what we want? Vertical axis. F of y is equals to f cos theta. And then sin theta. Sin theta is equals to what? Opposite side divided by hypotenuse. Opposite side is what? Opposite of the angle. This is the opposite of the angle. What is this? F of x. Hypotenuse is f. So sin theta is equals to f of x divided by f. What we want is f of x, horizontal component. F of x is equals to f sin theta. We have got this to conclusion. What it is? When the angle is with respect to x-axis, for any force, when the angle is with respect to x-axis, f of x will be f cos theta and f of y is equals to f sin theta. And similarly, when the angle is with respect to y-axis, the cos theta, f of y is equals to f cos theta and f of x is equals to f sin theta. Reverse of this axis will get. And now let us learn about the sign convention. What are the signs to be taken? How the force will be decided, whether it is a positive force or negative force. That is called it as a sign convention. This is our convention which we are adopting for the analysis purpose. Next thing, let us see this quadrant here. We have 4 quadrants as we know. This is our first quadrant, second quadrant, third quadrant and fourth quadrant. And as we know, these are our 4 quadrants, and here this side is positive x, negative x, positive y and negative y. This is the system which we are going to use for our analysis purpose. How are we going to use? See here, when we get an inclined force like this, F, and horizontal and vertical components will be like this after resolution, as it is in first quadrant. First quadrant is F is positive, Y is positive. So rightward forces will consider as positive forces and upward forces will be considered as negative forces. We can also check here in the second quadrant. This is the shape of our second quadrant. Here, if the force is like this, and here vertical component we have, and here we have horizontal component. So what we can see here, F is negative, Y is positive. Why? Here the F force is leftward force is negative, and again upward force we have, upward is positive. Check here, this is our third quadrant and the force will be like this, and here f of x will be like this and f of y will be like this. Now here this f of x, it is left side, and vertically downward force f of y is downward it is. So we can say here from this, leftward force is negative, downward force is also negative. And in our fourth quadrant is somewhat like this. This is f of x, force here f and f of y. From this what we can say, rightward force is positive, downward force is negative. In general, what we can write is, rightward forces are positive forces in case of horizontal, leftward forces are negative. And similarly, upward forces are positive forces and downward forces are negative forces. Rightward force is positive force, leftward force is negative, upward force is positive, downward force is negative. This is our sign convention. It is really simple and it remains same for each and every problem. So let us solve one problem, one numerical, which we have to consider here. For this problem, before moving to any problem, first let us see resultant of the forces. What it is? Resultant of forces. You have number of forces. Likewise, F1, F2, F3 and F4. Say you have number of forces like this, and you have to get the resultant. Resultant is what? The sum of all the forces, the result of all the forces together as a result, how they are acting on a particular body, that will call it as a resultant of the forces. As we know, these forces are inclined forces. You have to resolve in f of x and f of y components all the forces. First you will resolve whatever values you are getting in terms of f of x and f of y. Next thing, when you have to calculate the resultant, what you have to do is, resultant formula you have to take. Resultant formula is square root of summation of f of x whole square plus summation of f of y square. This is our resultant. This is a formula, you have to remember this, and for this you have to calculate this summation of f of x. Summation of f of x is what? Summation of all the horizontal forces. Example, fx1 plus fx2 plus fx3 plus fx4 is equals to summation of f of x. Whatever the answer you are getting, you have to just square this answer. Next, again you have to consider f of y, that is vertical forces. Summation of all the vertical forces you have to consider, that is fy1 plus fy2 plus fy3 plus fy4. After taking the summation, next step is what? Taking the final answer, summation of f of y, and then squaring this value again. After squaring, now substituting in this resultant formula, r is summation of f of x whole square plus summation of f of y whole square, and simplifying what answer we are getting, we'll just write it down. And the direction, at what direction is nothing but the inclination of the Resultant for inclination is always with respect to x-axis here, because we are considering the tan inverse sigma f of y by sigma f of x. This is the formula. Here, by seeing this formula, we can see the theta angle is with respect to x always, because what it is in numerator, f of y by f of x, vertical, opposite side it is, opposite by horizontal, and here it is tan, sine by cos is giving a tan. Means what? First you are considering the vertical axis, then you are going to the horizontal axis, and here you are dividing it. So it gives an idea that the angle is with respect to x-axis, resultant. So after knowing all these things, we have to move towards one problem. Let us see this problem here. Find the resultant of coplanar concurrent forces shown in the figure below. This is our figure here. We need to find out what? The resultant of this force system. The resultant of force system. Sorry, my stand is getting shake. Okay. We have to calculate resultant of these forces. Before solving any problem, you must know these basic values. This is what are angles: 0 degree, 30 degree, 45, 60, 90. You may exactly not get these angles only, but you have to remember at least this much. This helps in your simplification. Okay, now start resolving these forces. How to resolve? As we can see, there is very first force, naming the forces here. I'll say this force is F1, F2, F3. Is there any force here? Downward force. We have F4. We have four forces here. Here F1, as we can see, it is on our horizontal axis, need not to resolve this force, and F4, it is on our vertical axis, need not to resolve. Only two inclined forces we have. One is F2, 400 Newton, inclination is 60 degree with respect to x-axis. Another is F3, 300 Newtons, inclination is 40 degree with respect to x-axis. Now resolve these forces. How it is? Just take exact shape how it is. Only but one force at a time. Here it is 400 Newton, right? An angle of inclination it is how much? 60 degree. Horizontal component f of x is what? F cos theta. So what we can write here? F is 400 cos 60 degree. And vertical component is f sin theta. That is what? F is 400 sin 60. One force is resolved here. Now next force, exactly same shape we'll draw how it is. This is our force here, 300 Newton. Angle is with respect to what? X-axis. So angle, if it is with respect to x, horizontal comes with cos theta, vertical comes with sin theta. So horizontal is f cos theta, that is 300 cos 40 degrees, and vertical is f sin theta, that is 300 sin 40 degrees. Now let us do the summation. While doing the summation, we can consider forces along one axis. We can consider at a time one axis at a time. So that is either we can start with x-axis or we can start with the y-axis. We will generally start with x-axis. Whichever you feel convenient, you can start. Now let us see summation of f of x. All the horizontal forces. Very first force F1 is what? Horizontal force, and it is rightward x-axis, 300 positive. F of 2 is inclined. We have resolved into horizontal component and it is towards right. Horizontal force is towards right. So plus it is 400 cos 60. And next third force, that is, this is our third force, 300 Newton, and it is leftward. Leftward means what? Negative here. Force is 300 cos 40. Is there any horizontal force? No. One force is horizontal, that is done. These two are inclined. We have resolved line already taken, and no other force. Fourth force is vertical, so we don't have to consider in the horizontal case. After getting the solution, we have to use your calculator and get the solution for this. You will get your answer as 270.2. 270.2 what newtons we have taken here, so we can consider it as 270.2 newtons, and do it as a square, sigma f of x square, because in resultant we have to sum it up. So that is sigma f of x square. Sigma f of x square, what we are getting here, 73008.04. Now check for sigma f of y. Sigma f of y is what? All the vertical forces. So F1, start with the F1. This is horizontal, no vertical component here. So it is 0. And the second force is inclined, and the vertical component is 400 sine 60. It is upwards, so positive 400 sine 60. Next, our force is 300 Newton. Again, after resolving, the force is upward. Upward means positive. Force is 300 sine 40. The last force f of 4 is downward. Downward is negative, so minus 200. F of y will get answer as 339.24, and f of y square, for resultant purpose we are doing this, 115088.15. Cross verify with your calculators, and then we'll go solve for resultant. R is equals to what? Root of f of x square plus f of y square. So therefore R is equals to, we'll get 433.69 newtons, and inclination theta is equals to what? Tan inverse of sigma f of y by sigma f of x. That is tan inverse of f of y is 339.24 and f of y is 270.2. So we'll get theta as 51.46 degrees. So where this force is acting, if you want, you can draw it here. This is 60. So resultant will be below 60, 51. You can mark it here, resultant R, and angle is 51.46 degrees. Resultant is how much? 433.69, or you can make it as 7. This is our resultant. That's it. Thank you for watching, guys. Do subscribe my channel for upcoming videos. All the videos will be related to the same subject and the continuation of this only. Thank you.